Hi everybody, this is Tim Urdan, author of Statistics in Plain English, and in this video I'm going to demonstrate how to conduct and interpret Wilcoxon Signed-Rank Test on SPSS. So the Wilcoxon Signed-Rank Test is the non-parametric rough equivalent of a paired t-test. So again, you use non-parametrics tests. I mean, you can use them instead of parametric tests. They'll sort of tell you similar things, but generally non-parametric tests are used or favored when the data on the dependent variable or two variables, in this case, might not form a normal distribution. So I'm going to show you how this works. So in a paired t-test, you're comparing the same sample twice. Often you're comparing them on the same variable measured at two different times. So that's what I'm going to do. In this data set, I collected data from high school students over a few different waves. So like the fall of this academic year and then the spring of the academic year, and the fall or spring of year one, and then again in year two. So let's take a look at a couple of these variables. And this one, value, wave 2, is in the spring of the first year of the study. And what I'm looking at here is how much students say that they value their work in their English class. So value is things like, I think the work is interesting, I think the work is important, I think this, what we learn in English class is going to be useful to me later, that kind of stuff. So I want to see if students value what they're learning in English more at the end of 1 year, so spring of 1 year, or at the beginning of the next year, which would be fall of the next year. So I have wave 2 value and wave 3 value. So I'm going to compare those two with the same sample of students over time to see if there's a change there. So I go to Analyze, and I go to non-parametric tests. And this time I'm going to choose related samples. So that's related samples means either it's paired or matched samples, or it's the same sample measured twice, which is what we're doing in this instance. So I click that, and I go to Objective, and I can customize my analysis and pick which one I want, or I can let SPSS just look at what I'm trying to do and decide for me what the best test is to use. Either way, I'm going to end up with the Wilcoxon test. So let's go to Fields, and this is where I can plug in the variables that I want to look at. So I want to compare value at wave 2, which is down here, value of English classwork, wave 2, and the value of English classwork at wave 3, which is here. Okay, so I got the two variables that I want to compare, and I can go to Settings, and I can here customize the tests, and here I do a Wilcoxon match pair rank test if I want to, or I can just let SPSS do it for me, and it's going to come up with the same test. But if I didn't want to do a Wilcoxon, if I wanted to do something else, I could pick some of these. Test options, I can fiddle with the significance level. I'm going to leave this at 0.05 and the confidence interval. I'm going to exclude cases. Test by test, I'm only doing one test here. So test by test or listwise will be the same thing, but let's just go listwise. And then this is saying, what do you do about the missing values? And I'm saying exclude all the missing values. And I hit run. All right, and this tells me the results of my Wilcoxon Signed-Rank Test. So the median of differences between value of English wave 2 and value of English wave 3 equals 0. That's the null hypothesis. So we are looking for the median difference in ranks So you line up all the scores on the first variable and you rank them. And you line up all the scores on the second variable and you rank them. And then you compare them and say, okay, is the ranking that a particular person in the sample got on the value at wave 2 higher or lower than the value that they got on, or the ranking that they got on value variable at wave 3. So you're doing all of these comparisons of ranks for the individuals, comparing their own ranks to each other at the two different time points. And you're trying to see if the rankings shift much from time 1 to time 2. So ultimately you're looking at the median ranking. Does that look like it's quite different at time 1 or time 2? Significance level here, this is a p-value, and that p-value is greater than 0.05. That is telling us that there is no significant difference in the median ranks from a value at wave 2 and value at wave 3. No change there. And it tells us to retain our null hypothesis. Down here we can see some of the relevant statistics. Our sample size was 725. That is our observed value of our statistic, of our test statistic, which is quite high. And again, it's not significant. So this is a summary of the comparisons of the rankings at time 1 or time 2. And what we see is that there were 304 cases of positive differences. That is, the ranking from time 2 to time 3 went up. So the value increased in terms of the ranking. Somebody who might have scored, 50th in the sample at time 2 is likely to have gone up a little bit, maybe to 45th at time 3. So it's looking at changes in rankings. There were almost as many negative differences as there were positive differences. So when you see that, you can tell that the average change, or really the median change in ranking over time, is not going to be all that different. If there's about as many people who went up in ranking as there were who went down in ranking, the median ranking change will not be very different. And we can see that when there was a change, the change was very small. So we weren't seeing a lot of dramatic changes in ranking where somebody went from being near the top of the ranking, most strongly valuing at time 1, and then dropped down to the bottom. There were very few large shifts in ranking, as we can see. This is a scale from 1 to 5, so there weren't a lot of people that just went from 5 down to 1 or 1 to 5. So most of the rankings were very small, or the changes in rankings were quite small, and there were about the same number of positive changes as there were negative change. All of that adds up to a non-significant test statistic, which is what we found here. And then if you go down here, it just shows you the distribution of each of the variables that we looked at. This is just frequency distribution for valuing of English classwork at wave 2. And again, frequency distribution for valuing of classwork at wave 3. And if you kind of compare these, they look really similar. These distributions look quite similar. And that's another indication that there's probably not a big amount of change from time 1 to time 2. So that is how you perform a Wilcoxon Signed-Rank Test in SPSS.